also love the music still. Even after all these years, I still like the music. So that's good. Good evening, all. My desk is still in the same state as it was before. Total mayhem. Any minute now, headbanging Quindor, oh no. The sun is still outside, so the white balance and everything is off. It'll correct itself during the stream. Today we're going to continue the PCB schematic component selection bonanza we did last week too. And I think we're going to try and, you know, draw some more schematic. Oh, let me update KiCad because we're in the pre-stream. It's always good, right, to update things while you're, not even before the stream, while you're already streaming. It's the best time to do it. But hey, when else are you going to do it? Will there be magic smoke or pink LEDs in this stream? We might integrate a pink LED. We could do that. So let's see. There. It's downloading. It's 1 gigabyte. A whole gigabyte of PCB design software. There's too much crap on my desk. So now I can't move my mouse. So let me move some of that stuff. Prototype controllers. Okay, I think we're good. Hello, Hekamos. 1978. You're 1 year older than I am. It's still downloading. It's slow today. There we go. Install. I'm not going to show this process. What are we all drinking? I was in the supermarket today and I saw they had Hero Cassis Zero. And it's like, okay, let's give that a try. Oh, they say 0% added sugar star. The star is worrying me. Yeah, it has a little bit of sugar because of the juices they probably used in there. It's okay. It's okay. Thanks for reminding you. Yeah, no problem. No problem. Oh, here's it. Where? There's too many screens. There it is. Because the KiCad 10 is still very new, so let's update it. No, I actually went to the Jumbo. 71. Ah. Banana liquor from Tenerife. Ugh. Okay. I'm not much of an alcohol guy, so. I don't know. Let's download this too. And let's feed it to the AI. We're going to be working with AI a bit because I haven't had too much time to look into the documents this week and figure out that whole transformer inductor whatever discussion. So we're going to ask AI. But a better AI than last week. Tastes like pear drops. Oh, okay. So I have this theory that differencing from people to people, their alcohol taste is very different. Me, for instance, I can smell alcohol from like meters away. And even if someone says, "Oh, here, taste this," there you barely or you can't even taste the alcohol. It is so overwhelming to me that I only taste alcohol with maybe a small hint of some other flavor in there. And the more alcohol that's in there, the worse it gets. So even with beer or other stuff, I basically taste alcohol, and I don't like the taste of alcohol. And so anything alcoholic just tastes horrible to me. And I think this like differs between person to person. So some might be very susceptible to that, and others might be less susceptible to that. So then the normal or the actual taste of the beverage takes precedence over the alcohol flavor. It's also there, but as an undertone. But for me, it's completely the reverse. And yeah, if you then don't like alcohol, yeah, I don't know. No, we're going to use Claude. We're going to use Claude today, and they introduced a new Fable model this week. And so we're going to use that to figure out the datasheet and what kind of transformer or inductor, if we're going for a non-isolated design, we need. Are you saying smoke? What? AI is there in moments like this. Exactly, Savak. Yeah, we were just going to ask AI, and maybe that'll get us started. AI, Gemini can invent parts. No, we'll ask it to actually check on LCSC. I should have maybe installed an MCP for that. You have like MCP connectors you can connect up to stuff, and I believe there's also one for LCSC now. But we're just gonna ask Claude. Claude, you do it for me. Make no mistakes. Alcohol is a good way to clear your memory while still being an ass. I mostly see the latter part. I don't know about the first part, but yeah. I've played around with Fable a bit this week, Rob. I think it's another quite decent upgrade above Opus, which I've also used before. I've played with local AIs because I have an RTX 1590, so you'd say, okay, you have like the consumer video card for that. And for image generation and stuff like that, it's pretty decent. But for generic AI tasks like guiding you or helping you with developing something and things like that, those cloud models are a lot better. There's no competition. I mean, maybe you can use some local stuff, especially if you invest like 10 or 20,000 bucks, and then they might get close to the worst levels of the cloud versions, but nowhere near the best versions. So yeah, I've seen that happen before, Rob. Yeah. But that was also mostly when I was still using Perplexity. I've mostly switched to Claude directly now, because the better models feel a lot more helpful to me. Yeah. Oh yeah, you have prompts for Claude. Yep. Yeah, I have some skills and stuff like that in there too. Opus for at work for coding. Yeah. I mean, love or hate AI, and the current way AI works is not sustainable at all. I mean, my current view on it is we're not so much in a bubble because the technology and the use cases are real. We are in a bubble, however, at how much it costs. Like this month, I had to do a lot of work which I wanted to automate using AI, so I got the $200 Claude subscription, which is a lot of money. But using that $200 Claude subscription, I estimate that I burned Claude through about 5 to 8,000 bucks worth of tokens. So they're selling you this for 200 bucks, and if you use the API, they charge you 4 to 5,000 bucks. But their real costs on the back end will probably have been 7 to 8 to 9,000 bucks. And the goal is to make everyone, well, basically addicted to using AI, and have companies integrated wherever they can because, hey, it's AI, it's working great, and it doesn't cost too much, and everything is great. And then slowly over time, in the next year or so, they will keep raising the prices and lowering what you get to the real cost of what the AI is actually costing. And then the companies which now integrated AI into all their workflows, they're screwed because, well, they'd have to integrate AI in from all their workflows and hire back people who actually have intelligence and all kinds of stuff. So they're probably not going to do that. And I think a lot of businesses who do that now, if they can't become sustainable without or with reasonable AI costs, which currently aren't, they'll fail, they'll go bankrupt, they'll just die. And others, might make it out on top. But yeah, I mean, what we're paying for AI right now is like 1/10 of what it actually costs, and I'm going to make good use of that. I'm going to be honest, but I also keep in mind that what we're getting now is not sustainable. And of course, there is what the AI companies are hoping for, I believe, is that the technology catches up fast enough to basically catch the problem with the pricing, and at some point we'll have like 5 generations more of technology which lower costs, and then with raising costs basically for the user, they end up at a parity where with the new technology and a reasonable cost, things are sustainable and profitable. But we're nowhere near that even happening. They're burning millions, I don't know, a month to serve these users to make sure they're hooked on their product. But then the technology will not catch up fast enough to make that happen. Maybe in 5 to 10 years. Sure, in 10 years, the AI that now I burn through like, let's say 10,000 bucks in a week, will cost like 500 bucks or 100 bucks on the provider side, right? So then if I had to pay 200 bucks for that, that'd be profitable for them. But we're nowhere near that, and at some point they can't help but have to raise prices to compensate for that, because it's a we need to get them hooked before we raise our prices type of deal. Is my car going? Oh yeah, my car's fixed. That was weeks ago. Yeah. I replaced a $50 speaker, and all problems resolved itself. Instead of paying 4,500 bucks to the garage. Do not forget to destroy the hardware market. Yeah, absolutely. So currently it's a race to the bottom, basically, and some will fail, and some might make it with enough investor money and maybe become profitable. But yeah, and I mean, with this hardware race, like Philip mentions a good point, all other sectors in the world are suffering because of this. Even me, my prices at the back end have raised about 30 to 35%. That's split between raw costs for the PCBs, so PCB material, epoxy, gold, hassle coating, etc., has all raised 30 to 35% just because the resources are now more constrained because so many PCBs need to be made. The prices just go up, right? In the end, it's whoever pays most gets it. So prices for everyone go up. So my margin on my products has gone down by 10-15% from January to about now. or maybe it started slightly earlier last year. And that also components. Some components just completely ran out. Some they aren't making anymore because they favor making other stuff which is more in demand, so they can ask more money. And other components just suddenly tripled or quadrupled in price. So, yeah. Yeah, so even just on the resource side and the PCB manufacturing side is not that much hit because the processes the AI companies need is a much more advanced process than we make our stuff. So that's still been okay. But the raw materials themselves, those have been hit. And some of the ICs and things like that. It's just, yeah. Oh, nice, Sarko. You have a Quen 3.6 on a DGX Spark. Yeah, I like the DGX Spark. I maybe, if I can swing it, I don't know yet. Depends on the prices. I might get one of those laptops. They seem interesting to me. But you use Claude Max subscription to optimize local scripts. Yeah, so what I've been doing is I also use the Claude Max. I only have maxed this month. I already put it back to Pro because $200 a month is a bit rich, but this month it really paid for itself. But I have Claude generate prompts for my local Comfy UI to generate images using my RTX 5090. Because for a big model, the RTX 5090 has only 32 gigabytes of VRAM. It's not enough, but for image generation, that's plenty. So, yeah. We get to the point where we have to have AI to do our R&D because we can't afford the equipment or labor costs to do it manual. Yeah, maybe. Yeah, sure. Oh yeah, Philip, memory is insane. I have 3 4 terabyte SSDs in my PC, 2 990 Pros and one 9100 Pro. Those were like €250 a piece, and then the 9100 Pro was like 300 something. And I like buying SSDs big because I know they'll last me 10 years, and it's better for me to now buy a 4 terabyte model than buy another one in 2 years or in 3 years or whatever, like if I buy a 2 terabyte one. So, and SSDs, if you buy a bigger one, it has more cells, so it will actually last you longer with the same usage, right? It doesn't matter if you store more on it, the write cycles depends how long it'll live. So with the same usage pattern, no matter how much you stored on it, it'll just last twice as long. So that's why I buy big SSDs or NVMe drives or whatever, and then I use them for 10 years. But those were like $250 a piece. They're now over $1,000 a piece, and the 9100 Pro, I don't even know. Let me look it up. 9100 Pro 4 terabyte. Let's see. Tweakers. Oh, it's actually less than I thought. They're about $600, but I paid like $300. So, yeah. Yeah, exactly, Savog. I mean, I have 96 gigabytes of memory in my main PC. That was like $300. That's now $1,000. I have a 5090 I bought for like $27.50, something like that. I don't even know what those are now. Let me look it up. Price watch. How can I search? Whatever. Tough 5090 should work. Oh wow, it's 4,100 euros for the cheapest shop. I bought it for $27.50. Oh, nice, Kiwi. Yeah, you can do some local stuff with that. So, I mean, I luckily bought all my PC components right before this insane price hike hit. So I'm going to ride that out for years. But yeah. If you have to buy the same stuff now, I just wouldn't, because it's too expensive. Yeah, I mean, those SSDs, I've always had that mentality because I've been playing with PCs for tens of years. I'd rather buy a, I don't know, 18 terabyte drive than a 10 terabyte drive, even though it's like, it scales linearly, right? But I can use it for longer. So, and especially with SSDs, you also get more longevity out of them. Yeah, prices are just insane for computer. I'm glad. I also did like the triple node server upgrade clusters and things like that. Those also all have 96 gigabytes of memories and SSDs and blah blah blah. I did all of that before the price hikes, because right now I just wouldn't. It's just way too expensive. Yeah, glad you bought an RTX 5080 when you did. Yeah, I mean, from what I'm hearing is that they're going to bring out a super variant of the current 50 series. So that's already a year late, right? Normally they do that after a year. It's now been 2 years, and then probably they'll ride that out for another 2 years. So we don't get a new generation in 2 years, but we get a new generation in 4 years. So I'm very happy. My streaming PC, I got a, what did I pay? I don't know, $700 for a 5070 Ti, because the 5070 Ti has the dual video encoders, and I sometimes encode multiple cameras at the same time, so I wanted to have the dual video encoders so that I can do like 4 or 5 AV1 streams at the same time. Yeah, that's now, can you even get those 5070 Ti's? 5070 Ti. Yeah, no, I want the, what's the cheapest one? Pricing? They don't exist anymore, or what? Let me check. That's funny. This website's broken. Okay. Best. Oh, there's just no prices. Okay, 5070 Ti here in a different shop, $1,200. Oh, that's a Strix. Okay, I don't need a Strix. 1,100. Yeah, about 1,100. Yeah, I got it for like 700, something like that. That's still manageable, but yeah. Savag, yeah. Storage too, yeah, for sure. Remember I did that Chia project? Well, those drives have all been repurposed. They are now my main NAS that I use for the company. Lindsay and Janice are watching as well. Hello. We're talking about how AI made all computer parts very expensive. And after that, we're going to use AI. Anyway, yeah, I mean, love it or hate it, AI is another monumental shift, I think, in technology that's available to us, like the internet or, I don't know, other stuff, modern graphics cards and blah, blah, blah. It's definitely a paradigm shift in our history, I think, enabling us to do more. But it doesn't come without a cost, that's for sure. Oh, I am definitely a hypocrite in here, because I know it's not sustainable. It is not sustainable at all. So I'm going to use the crap out of it right now. And then once it skyrockets in price, which it will have to, because or like Claude goes bankrupt, Anthropic or whatever, I don't care. I mean, they make this available to me. I'm going to use the crap out of it, and then Sure, Greg. Well, it's not in itself evil. How they're building it up and the resources they're spending on it right now which is causing all kinds of other issues, that might be a bit evil. But yeah. Biggest change the microchip? Yeah, maybe. I mean, I don't think in 5 to 10 years we can imagine a world without it. Just like we can't imagine a world without our cell phone or the internet or Netflix or your car as it is right now or whatever. Even like what we're doing right now, streaming live on the internet. 20 years ago or 50 or 10 years ago that was a thing. But I mean, I remember these things in my lifetime, you guess how old I am, where these things didn't exist, and now it's impossible to imagine that they don't exist, right? So I think AI is one of those, is a similar change for humanity. Yeah. Yeah, I know. But it's fun to have a discussion about this, right? I mean, you can have a different opinion. That this is my opinion, that it's not sustainable whatsoever. But yeah. Let's see. I'm looking at my tabs here. I need to drag some things in a new browser. One moment. Okay, this needs to go away. Hold on. I will share a browser soon. Okay, so this we don't need. This now goes here. Okay, let me share this browser. I think we're gonna go here, and then browser window. Yeah, I'm gonna make it a little bit more transparent. Sure. 10 years ago, if you told me I would make money for doing videos, I would have asked what you've been smoking. Yeah, exactly. I mean, so let's go to our AI, or rather, last week we kind of selected this chip, and by doing some research, we kind of found that this chip is the same chip as this chip, right? Because we looked at our eval boards. Oh, I don't have that one open. Anyway, we looked at the eval boards, and it turned out that these looked very similar, and I think they're actually just the same chip, but it's been cloned or OEM'd or something like that. But I've opened Claude, and we'll put it on Fable Max, Effort Max. Let's go. Okay, you can see it. Yeah, okay. So we're gonna use my I have a $200 Claude subscription just for this month because I needed to do a lot of web hosting move work and things like that, and that would have taken me way too much time. But Claude helped me with that, and now it's all done, and it's great. So I have this subscription for this month, so we're going to use the heck out of it. Now I've created a project in Claude, and I've called it Wall Panel Sensor, and I've told it what we're doing. We're building an add-on PCB for the WaveShare 86 wall panel display with ESP-P4 inside, blah, blah, blah. And I've just fed it the 3-peak... we need this name. And the MPS data sheets, because it's always good to give it the data sheets instead of trying to get it to make it get them itself. because it's just better. The more information you give it, the better it is. So yeah, let's write a prompt here. I'm trying to develop a PUE add-on which takes in I can't spell today, sorry. PUE, and then outputs 5 volt. Looking online, I've found the 3-peak and MPS which look really similar to me, and I'd like to use that IC to accomplish this. I don't know much about transformers. Oh wait, let me zoom this in for you. But do know inductors. If this is a standalone wall panel, does it need to be isolated or not? What kind of inductor do I need for 5 volt? Oh no, wait. Okay, transformer or inductor do I need for 5 volt? And can you find me one on LCSC? This is Claude.ai. Do we need to tell it anything else? No, I'm pretty fast in typing, and with voice I have to think all the time, and yeah. Oh, because a lot of CDNs are actively blocking bots from downloading PDFs. Yeah, true. I use Claude. Let's hit enter and make it do its thing. Generally in the desktop app, and it depends on what I'm doing. If I'm doing research, it's just using search, and if I'm doing other stuff and it needs to do stuff for me, I use Claude Code. Now we're going to burn through some credits here. Let's see how many credits we start with. Let's see here. We're currently in an hour, our window, our 5-hour window or whatever, session window resets in 1 hour and 15 minutes, and we're at 14%, and my weekly I'm at 7%. Okay. Act like an expert makes it hallucinate crap sound makes the hallucinated crap sound more true. No, I don't need all those things, Kiwi. I don't want notifications. Go away. I don't care about this either. Use all the resources. Well, Claude is working. I'm going to enjoy my Sprite. This is what the modern world is, right? It's researching everything for me. Good. Oh, okay. It found all the PDFs and it's researching those. I also added a how to optimize a PUE design PDF. So I found this PDF here. It's from MPS. And I believe they also mention the IC we're trying to use, the MP8017. So I also fed it that information so that it can use that, to become more knowledgeable about the subject. PD plus DC, DC, low voltage buck, yeah, sure. I mean, that's still an option. We could still PoE to 5 volt or 12 volt and then buck it down, but I'd rather not if we don't have to. What could possibly go wrong? Exactly. I don't know what they're... Oh, they're talking about various transformers here. You can get a smaller transformer because of the switching frequency. Sure. Oh, they have the spread spectrum, but they call it the frequency dithering again. And the optimized gate drivers. That's good. Active snubbing. Oh, okay. Anyway, let's see what it's doing. Oh, okay. It's researching the PDS and then transformer turn ratios, because we don't know anything about that. That was obvious last week. Bill of materials, okay. Yeah, that's good. It's analyzing everything. Isolation requirements, all kinds of stuff. Good. Good. I get to talk to you guys. Your ChatGPT acts very aggressive by default. Wow. Is it still readable, or is now the transparency too much? No, I'd say that's still readable. So, okay. And list exact project file names and test PDF income. Oh, okay. I didn't tell it that I wanted to use the 3-peak one, huh? Well, maybe you can do that. No, it's slow because I put it on max thinking mode. It needs to have like the max intelligence. I think this research alone will burn like through 10% or 20% by the time we're done. Oh, it's running scripts now. No clue why. It found the transformer part number in the EVM bomb text. At this point, it's as far as we were last week. Oh, it's now looking at non-isolated inductor applications. Good, good, good. Is this what live streaming has become? Watch YouTuber use AI? Exactly, Philip. I've never had the AI treat me like God. Why is it doing that? It just treats me normally and does what I ask it to. By the time I got on the same page as me, it said, "You have used up your free time." Yeah. No, I don't think everyone here does. I do, generally speaking, but yeah. The goal today is to have a somewhat basic schematic of the PoE circuit drawn, right? So that's the goal for this live stream. How to promote like Quinder like a pro. Yeah, exactly. Oh, prompt. Okay. Oh, okay. It said something. Now let me look at the EVM schematic page more closely and then verify actual parts on LCSC. Now, remember, this is not what I asked. I only asked it about transformers and about transformers, and it's doing the whole design for me. I guess I don't know. can't talk to that. No worries, no worries. Oh, it's cross-referencing forum discussions now. I think I can. I think I can figure out which forum discussion that is, because it's probably the same one. Oh, God, this is a different IC. The same one we looked at. I need to reconsider my approach since WebFetch has restrictions on which URLs I can access. The AI is getting blocked. I should install a connector where it can connect directly to a LCSE database, but I haven't done that. Okay, it's starting to realize that it's being blocked. It can only access exact URLs. Okay. Nope, still not getting it. Oh, it's trying other websites to now find direct links for LCSE. Oh, now it's found the LCSE product page for the transformer. Oh, okay. Let's fold this back. Oh, it found that the transformer isn't in stock at JLC PCB. I haven't used Notebook LM yet. No. With one prompt, Quinder uses up his entire token budget. Let's see where we are. I don't remember what I said the numbers, but I believe we were at 14%. it's going up. We're using like the most expensive model on earth to do this research. I don't know if that's smart. But hey, I've got these credits, or this package for this month, so better use it. At the end of the stream, as a secret, I'll show you what I did with it. Is this one of those we do this so you don't have to moments? I don't know. I think if you're going to use AI, use a smart one, but then you're going to have to pay for it, right? It's going to use up all your tokens just trying to block links. Yeah, maybe. Oh, it can do connectors. Okay. Skills. Yeah, so maybe I should have added a connector, because I found one. Let me check my bookmarks somewhere. So I found this connector, but I haven't added it yet. So this is PCBparts.dev, and they host an MCP server, and an MCP server is something you can tie into AIs, basically. And you can add it to Claude, and then it can find certain types of modules, but also I believe it can look for JLC parts, JLC stock numbers, alternatives. It can do DigiKey, Mouser. It can get KiCad schematics, I guess, or footprints or 3D files. So I bookmarked this one that I needed to look into it, but I haven't done that yet. But this basically makes your AI smarter, because you give it more skills, because now it's just trying to brute force finding this stuff, right? So that's going to burn a lot of credits, going to take a long time, and it's just not very efficient. It might work in the end, but it's just not very efficient. And if you give it access to more skills and connectors like this, it can then say, oh, I now have a JLC search command, and then look for the part, and it would have been done in 2 seconds instead of spending minutes trying to brute force its way into LCSE, right? Oh, it has no API key or login. Just connect and search. Pricing tiers? Okay. Is there pricing? Can you add it now? Yeah, I don't know if this works in... oh yeah, settings, connectors, PCB parts, add. Yeah, oh, maybe I can. Oh, YouTube stuttering. I have 0 dropped frames, and yeah, no, I'm good. I don't think it's me. Could be, but oh, how much current does the panel actually need? Well, I want to have about let's say 0.5 nominal with about 1 amp peak, right? So we're going to say we're going to use 2.5 watts, so 5 volt to half an amp. 2.5 watts nominal. It's probably going to be lower than that, but who knows? And about 1 amp peak, okay? Besides RJ45, does the panel have any of these? USB or service port? It does, but we're never going to connect those at the same time, so we're going to say no. RS485 or relays? Oh, it might have a relay. Ah. Exposed metal or metal back box? It might, but still, it's going to be in a wall. So, I'm just going to write, it has USB, but will never be connected at the same time. It might have some solid state relays. Yeah, I know it's for isolate, but I'm going to tell it, it might have USB, but we're never going to connect PUE and USB at the same time, because then you need isolation, I know that. And it might have some solid state relays, okay? Oh, there we go, okay. Good news, I dug out your project files, and the 2 parts are even more similar than you think. The TPE 517 EVM are both 12 volt, blah, 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 flyback transformers. Literally the same transformer. This is all things we knew. The TPE is for all practical purpose sleeping, one spec internally, okay, AF. Same wattage. Sure. Okay, does standalone, generally no, okay. Requires isolation between cable interfaces and user-accessible conductive parts. If your panel is generally standalone, plastic or glass enclosure, yes. The RJ45 is the only wired connection, no exposed metal galvanically tied to your circuit. That's correct. The whole device floats and non-isolated converter is compliant and extremely common. Capacitive touch behind plastic glass is fine. The assumption breaks the moment you add a USB service port, RS485, relay contacts or other, an audio jack, or is mounted in a screws metal back box. Oh, contact to the ground circuit. Yeah, okay, that might be an American thing. In Europe, or at least in the Netherlands, we have plastic boxes in our wall, which might have metal screws, but they screw into the plat. They're not earthed or grounded or anything like that. Okay. Then you want isolated flyback. Worth noting, even the isolated IVM bridge is the carrier for EMI return anyway. Oh, okay. The non-isolated route is your friend because it replaces the transformer with a plain inductor. We talked about this last week. That does indeed make things easier. That's what I already figured. The internal low side FET, one inductor. For 5 volt, you change our feedback with a 1-to-1 winding ratio, 1.5 amp switching. Okay, so with a inductor, we can't get more than 1.5 amps out. Or no, the switch in the IC can't switch more than 1.5 amp. With no turns ratio to multiply, plan on 1 amp continuous, 5 watt. Okay, that's fine. We don't need more than that. Duty cycle is only 8 to 12%. Inductor average. So the peak, yeah, okay. Sizing at 500 kilohertz, but that should be okay with the EMI reductions this IC have. 33 microhenries gives us 0.27 amp ripple at 48 volt in, peak 1.25 at 1 amp load. Sure, that makes sense. So you want 33 microhenries, okay, with a saturation current of 2 amps. I've done lots of inductor work, so that's actually, that's easily findable. Okay. Oh, it found one for us. I verified the LCSC. Oh, let's give it a quick look. Hello? Oh, that's a big one. Okay, I'd want something smaller. Yeah, maybe a watt. Fonctionnaire, maybe 1.25 watt, something like that. Nowhere near 5 watts. Yeah, it probably chose this one because of the resistance and not so much the saturation, because saturation is 5 amps. We only need like 2 amp saturation. So I see it do this more often where it picks insane values for stuff. But luckily I know better myself, so that's fine. 5 amp saturation, yeah, it's 10 by 10. Lots of stock, it's not too expensive, sure. Generous headroom. I like molded inductors, that's true, but sure. Nicely sized. Okay, pair it with a 3 amp Schottky. Okay, that's fine. 10 micro input. Okay. Oh, here we have that mysterious inductor that we found in the AVM datasheet. Oh, in the UK you also have grounded, or earthed, I guess, metal boxes for your electricals. Interesting. Sure, yeah, sure, UK, that's true. Together with the MD frequency dithering, those are your main EMI. Yeah, okay, sure. Yeah, so it found that extra inductor, and this is probably because we used the most intelligent model on Earth. But it found the extra inductor we also did last week in the data or in the EVM, the testing board datasheet, which wasn't in the normal datasheet, and it also says it's a snubber or filter circuit for EMI purposes. So it's very smart that it figured that out, because it took us a while. The isolated 5 volt route is where pain is. You'd need roughly 4-to-1 transformer, mirrors the 12 volt 2-to-1 design point, 20 volt reflected, output diode 19 volt, 50 to 60 microhenries, and it's not an off-the-shelf part. I checked the E-volt transformer, shows 0 in stock. Well, that's what I use AI for, Fonctionnaire. I don't use it to do the actual resource with me knowing nothing about it. But it is good as a sparring partner to why are they doing this? Or I think they're doing this for this reason. Can you verify that? Or, this kind of stuff. This is a Claude Fable 5 on max mode. So isolated 5 volt realistically means custom wound magnetics or a 2-stage design. Clone the 12 volt flyback, add a cheaper 12 to 5 volt buck. Okay. Which also lifts you to the full 2 amps. Actually, hearing like the UK uses those kind of boxes, and I know the US does, maybe a isolated design is better, but trying to go directly 5 volt, maybe this IC just isn't really designed for that. It's more designed for 12 volt, but having a buck on there for 12 volt in to 5 volt down or out, or even 3.3 volt, because we mostly need 3.3 volt and maybe a little bit of 5 volt. He probably transcribed your live stream from last week. On the IC, on status is in stock and shipped a DigiKey. I don't care about DigiKey. Couldn't surf. Okay, sure. I won't claim it's there without seeing it. Very good. That's actually in my general Claude instructions. Don't tell me it's in stock or available if you haven't actually checked it, because it did do that before that. Oh, okay. Then we answered the question. Non-isolated single can, yeah, okay. But yeah, I might be leaning towards an isolated version. Oh, SSR are a non-issue. They help you. Okay. The solid state relay is an isolation barrier. Okay. So that's not a problem. Oh, the USB port I pushed back on gently. Never connected at the same time is a usage policy, and not the failure mode is the ground pin, not V. Okay, so okay, yeah. Problem is that if the two grounds connect together, so not the positives, so V-bus and whatever our PUE circuit is making, those should never meet, but that's, logical. But the grounds will always be connected. And he's saying that's not something you can fix with a diode or a mux. The day someone flashes firmware instead of an Earth desktop PC, your panel ground, which is non-isolated PD, gets bonded through a USB cable, and any surge inducted on the Ethernet now runs on that path to the PC. Yeah, that's why I said it would never be connected at the same time, because I know this. 3 honest ways to handle it. Increasing cost, make it a recessed service port so it's not reachable. Okay, sure. Full speed USB digital isolator. Oh, but well, okay, but we don't want to alter the screen part, right? And the USB part is here, and since we're not going to be changing that PCB, that's not an option. Or give up and go isolated flyback, yeah, which drags the 4-to-1 transformer. Yeah, okay, yep. No. This is not using a LCSC check yet. It can do some checks if it knows the direct URL, but we can try plugging in this PCBparts.dev and see if that improves things. Okay, concrete deltas. Okay. Yeah, okay. Yeah, it's saying, okay, you shouldn't deviate from their evaluation board too much, because that's what it got it through Class B certification, so EMI wise, etc. Sure. Okay, yeah, okay, sure. Classify as Class 2 only if you're tight on, okay, your 1 amp peak is 5.9 watts, okay, and the Class 2 classification is 6.49 watts. A 9% margin I wouldn't ship with. Okay. Class 3 costs nothing but allocation. Right. So the classes within PUE is, I believe, what your PUE switch, especially if you have an intelligent one, will reserve for that port. So if you tell it this device will use 12 watts, while in reality it only uses 2 watts, the PUE switch will be reserving 10 watts for nothing, which it won't give to other devices because it thinks that your device might use that. So this is what the classification talk is about. In our case, I think we could ship with Class 2 because the Class 2 ceiling is 6.49 watts, and I mean, we're going to use like a watt nominally and peak 2 watts maybe, right? So we don't need a 12 watt classification because we're never going to use anything like that. Yeah, okay, and it says that this is a good IC we chose because it has a sort of auto power signature where the PUE switch is not going to turn off the PUE because it sees very low power usage because it's going to pulse it every so many milliseconds with a little bit of current load to make sure the switch keeps it alive. Yeah, a PoE IoT device, yes. So, I'll make it a quick poll while I get another drink. Add connector or continue manually? Do we want to add the connector into Claude so that it can do better checks and stuff for us with LCSC? Or do we just want to do that manually and don't bother too much with all this AI stuff? Because kind of from this conversation, I kind of already know where to go. We're going to design a isolated 12 volt circuit. That's the safest for sure. Then we can follow the reference design mostly. And then we're going to add a cheap, 30, 40 cent buck converter behind that to make it either 5 volt or 3.3 volt. We have to see what we need the most of. And, we'll work with LDOs and other stuff. Yes to the connector. Just click, yeah. I'm going to get another drink. Oh, that's an overwhelming yes. Okay. Oh, sure, yeah. I generally don't add it to my products because I also feel it's too expensive and you can just get a PoE extractor. So, like, if 10% of my users are going to use a feature and it costs like a few bucks to implement, I generally don't implement it because, only 10% of my users is going to use that. In this case, 100% of the users is going to use that feature, so then it's something that I, should implement. Okay, let's... I don't get an end poll. Do I get an end poll? End poll. There. Okay, 10 votes, 90% yes. Okay, we're going to add the connector. So, according to PCBparts.dev, and it's an open source project, I believe, which has a GitHub and stuff like that. 6 hours ago. Seems well maintained. Yeah. No API keys required. Sure, cool. In their website, they say how to integrate it with the desktop. Or, sorry, we're going to use the web. Oh. Let's see if we can do this on the web, because I don't have the desktop client on here. Thanks, AF. So can we add connectors? Settings. Connectors. Okay. Customize. Okay. Plus. Custom connector. Okay. So far so good. Oh, it's an MCP server, huh? Okay, well, let's try it. Okay, so we're going to call it PCB parts. I'm going to call it PCBpart.dev. And this is the URL. Add. Okay. Oh, okay. So it found tools that it can now use using this connector. Yeah, you can, but, I tried to follow the guide. Get KiCad symbol and footprint. That's going to be nice. PCB design rules. Sure. Stock check. Live API. Okay. So let's go back to our project. And where's our chat? Okay, this is the chat. Okay. Okay. I've given you new skills to check LCSC parts using the dev parts. Do I need to enable the connector here? Oh, PCB parts.dev. Yeah. But the connector is enabled. We're going for a 12 volt out design, since that seems to make things a lot simpler. Can you suggest me a full BOM based on Okay, so I'm just gonna make it create the full BOM based on the reference design for me. I'll design the buck converter and things like that myself. That's no problem. And I'd like to use the 3-peak port. I don't know. This has become the AI show now. Let's go. Let's check where we are with burning my money. Oh, we're at 18% now. We started at 14%. This model costs the world. This is the most expensive model in the world, so it only released like a few days ago. It's now thinking. Oh. Okay, that's basically what we asked it to do, so that's good. And after that, we're going to transpose that into a KiCad PCB, basically. Oh, sorry, schematic. PCB is still many episodes away. Can you ask Claude to do that too? To make the schematic? I don't know if it's able to do that. Is there a Claude... let's see if there's a Claude KiCad skill. Claude KiCad skill. There's one for design reviews, but I don't think there's one to actually do the work. Yeah, no, there's one for PCB reviews, but not one where Claude will actually do the work for you. Later, Jamie. I don't know. I kind of like doing the work myself too, so I think we're gonna do that part myself. Yeah, I don't mind paying for AI when it's useful, and it definitely saves me some time doing certain things. Like, it's not the most expensive model needed for that, but it's a good research assistant. It shouldn't be the main primary research person. That should be you. And if you don't understand the things it's saying, you should do more research. But it can help you figure stuff out. Okay, let me pull the complete EVM BOM from your project files first, then verify every line against SC JLC PCB stock with the PCB parts dev tools. And that dev tool is what we just installed. No, I'm not going to do that. DFJJK. We'll do that part ourselves. We'll open up the schematic and then we'll draw it. Normally I would say asking is for free, but in this case, yeah, asking is definitely not free. Let's see if it did anything already. Oh, we're still at 18%. Okay. Reconciling available tools. Okay. Nah, yeah. It's now thinking about how to most efficiently do the bomb stuff. It's fighting with the tools we gave it. Wow. Okay, well, we'll let it fight. We'll let it fight. I don't know, DFGA, if you have like the most brilliant idea that you can't work out yourself, maybe. Oh, it wants to get part detail. Oh, okay. Can we say? Oh, okay. Always allow. Sure, do that. Now it's using our new tools. Tools loaded. Let me verify each bomb line. Okay. Oh, okay. It found. What did it find? I don't know. Yeah, you're allowed to do that. Oh, it found a transformer. Let's see what it found. Oh wait, no. This is the IC we want to use. Okay. Yeah, I haven't used connectors like this a lot. Generally in code you can put it in auto mode and then it'll do stuff. It's looking for all the components. The stock number was correct, 3095. Yeah, 3093, sure, that's correct enough. It's okay. I should have ever told it to look at like the 500 to 1000 number pricing, but that's okay. Yeah, maybe we can still do that. Let's see. Settings. Connectors. Oh, customize. Search reference boards. Sure. Sure. Oh, this is already enabled? Okay, sure. I don't know. It's allowed to do all these things. That's fine. All good. Let's do it. Oh, how much did we burn? It's going quickly. I'm not sure we should be using Fable 5 at max mode. Yes to all! Yes, exactly. Why do I look at 500 plus pricing? Because I don't have to source through LCSC. I do the sourcing myself or with my partners. so I can generally get cheaper prices. And if I produce something, I don't produce one. I produce a 500 to 1,000 because the pricing difference is very high. Yeah. I mean, I generally spend like, I don't know, a few thousand, or let's say a single prototype board can easily cost $300 to $400, while a production board can be $5 to $10. You know, so the price discrepancy there is very high. You burned through all your credits for nothing there, Johnny. But hey, I mean, if you need things to work, the response we got before actually influenced our decision, or my decision, I guess, because I was going to go non-isolated, but it kind of convinced me to go isolated, and I wanted to have 5-volt out, and it kind of told me, yeah, it's not really made for 5-volt out. So, you know. Oh, a customer pays for it. Okay. Yeah, if you want to use it more efficiently, DFGA, JK, sure, yeah. You use open source projects to learn the AI limits. Cool, yeah, sure. So far, I've been impressed with Fable. It's definitely better than Opus already. And I think it's currently the best one out there, depending on what you do with it, I guess, but... Yeah, this is burning. I mean, if like the discussion we had before, if you actually had to pay for all these API calls or all the tokens were burning, this research would probably have costed in the back end like $250, $300. That's no way worth it, right? I mean, and we'll get to a point where it is worth it, where like in 10 years, the hardware has become so efficient and can do so many more tokens with so many less watts and blah 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 that it would work out. But currently this is all skewed to hell and back. He wants his credits gone. No, I don't. No, my credits. Now I'm gonna get credit envy. No, I can use Sonnet. Okay, I can still use Sonnet if I burn everything. Okay, last piece. No, I paid the $200 because I had a lot of work it needed to do for me. But then it was done in 2 days or a day, and I thought it was going to take way longer. So now I have this subscription for a month, so I'm going to use it. Then again, it helped me move over from one web host to another, and that's going to save me $2,500, $3,000 a year, just because the new host is that much cheaper. So it paid for itself. I mean, yeah. Oh, it was worse. Okay. All passives verified. Okay. You do that. Live check real-time stock on the 2 linchpin parts. Oh, okay. Yeah, so where it had limitations before, and it was doing a lot of brute force searching, now it can do those tasks much more, maybe not efficient, but the results should be better and more realistic, right? We're already 1.5 hours in and we're still talking to the AI. Well, I think you can get it to import all the parts, but we'll mostly do that manually. That's okay. There's tools in KiCad for that also. Or maybe I can ask it to output a symbol and footprint library. We'll try that. I think it can do that. It's taking a while, though. It's taking its sweet time to do this, but the results should be good. And that's kind of true. That's kind of true. But I like drawing up schematics and thinking of things, so. Asking a human would take longer. Maybe. It would probably be cheaper. Not the way we're doing it now, but in actuality, with the actual costs, yeah, probably be cheaper. Four humans for 1/4 the time? What? I don't think humans work that way. Oh, here we go. Oh, yeah, it made the whole Excel thingy. Okay. Every line verified. Okay, let's. I'll get that back later. Okay, okay. Verified against stock, full BOM list. Transformer sourcing problem is solved because we went to 12 volt. Off-the-shelf PWE PD flyback transformer that drops into this exact topology. Nice. Okay. Oh, this is the flyback transformer. Let's take a look. Okay, yeah, that's one we looked at last week too, I think. But then we didn't select it because we still wanted 5 volt. 37, 2.1 amps. Okay, 1 to 0.5, so that's 2 to 1 basically output ratio. Okay. How big is it? It's not small. 13.5 by 13. Pricing is okay. Wait, where did it go? Go away. Oh, here. Okay. Okay, we need to input bridges. The EVM. Oh, okay. What? Do we need this? What is this? Oh, are these the rectifiers? Yeah, okay, those are the rectifiers. Okay, yeah, sure. So you can get a PWE socket with the rectifiers in there or not. We have to see. Some diodes. Oh, it selected more efficient diodes for us. Okay. So instead of 850 millivolt drop at 5 amp, this one has 600 millivolt drop, so it's more efficient. Okay, cool. And it's still, 10 cents. That's fine. TVSs, okay. Okay, and it selected a 58 volt version instead of a 60 amp version. Still 5 cents is fine. Input filter. Okay, that's the input filter that was in the EVM. No, but it has to do with the switching frequency, I think, DFGA. Total cost $3.20 per board at quantity 1, $2.60 at quantity 10. Okay, sure. primary inductance is 37 against 55 at 500 kilohertz with 48 volt in, 2-to-1 ratio, 24 divided by 72 primary ripple. Okay, so it calculated that we have a 0.86 peak to peak ripple. That's okay. Full 12 volt rating, that puts yeah, okay, 12 watts, sorry, 50% here. Actual 6 watt, sure. Totally relaxed. If you ever push the full and want margin back, okay, we can have a higher switching frequency, sure, but we're going to be way below that, so that's all fine. 3 things to check: the 1500 volt isolation, the aux winding stays unconnected, okay. Okay. C4 moved to 50 volt for less DAC bias rating. Sure, okay. Sure. Okay. We'll start doing this manually, but I think it's interesting. Can you generate me a KiCad compatible schematics symbol library and footprint library? Yeah, I think these results will work fine, and it selected LCSC components for me. I generally do the selection myself, even though AI recommends all kinds of stuff. I don't know if... No, I don't believe it can do images. But let's see if it can make me a library so that we don't have to do that ourselves. In the meantime, we'll do it ourselves. So we're going to follow the EVM schematics, because we're going to basically build the EVM schematics. This is the one for the 3-peak version. Oh, I don't have the... Let me open the EVM for the other one. Is it this one? No. Okay, I need to find it. Search. Do we have an EVM? Okay, the evaluation board. Oh, it has a 5 volt. What's this? So this is a 5 volt evaluation board. Do we have a datasheet? 5 volt out? Okay. Okay. So this uses the same IC. Well then, what kind of transformer do they use? Hold on. Oh, you can't see my... Oh, you can see my mouse. Okay. Oh, okay. These were the transformers we weren't able to find. Is it? Oh, we look... Oh, right. Okay, yeah. Yeah, probably. Okay. Anyway, we just need the schematics then. We'll use the 12 volt version, though. 12 volt... So this generates 12 volt out. Sure. Here they have a board that has the RJ45, the magnetics, and the rectifier. We're going to try and find that all in the RJ45 socket. If we can't find it all in the RJ45 socket, we might find one which has the magnetics, and then we do the rectifier externally, but we'll see about that later. So we're going to be copying this schematic basically. So they assume you have a DC coming in, so the rectification after the RJ45 socket is already done. We're going to assume that too, and we can always add that later. So we're basically going to draw this in KiCad using the suggested components that Claude told us about. But because we're basically going to build the exact reference schematic, including this weird inductor we found, etc. Well, we know what it's for now. Okay, sure. Let's see what it's doing. Won't exist in standard. Let me pull authoritative pin packages. Blah, 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 blah. Full pin table extracted. Now the mechanical drawings. Okay. Yeah. So PUE itself is more AC side, kind of, because it needs rectification to become DC again. And then you have the DC part, and that, you know, needs to be converted and stuff like that. So I need to see how I'm going to do this. I think I'm going to move chat up here. Let's see, KiCad. And I'm going to move my KiCad over here. And now I'm going to copy this. Copy. No. Rename. Oh wait, we had the issue that we had 1,000 KiCad windows. Okay, now I'm gonna do it differently then. Delete, remove. Yes, we're gonna do a display capture. Okay. We're gonna do that a little bit transparent. Let's see. Color correction. Oh, you can see the webpage still. I'm gonna move this down. Okay. Now I need to rescale it. Oh. Okay, so this is where we left off last time. We had the connectors drawn, and we added a terminal and some other random stuff. Sure. So let's take a look at that data sheet. We start with a VDD and VSS, and then we have a TVS. Okay, that's not too hard. So we're going to create a power net. So we'll have a VDD. And then we're going to add another power net. Oh, I think I have the power nets off the screen. Hold on. Yeah, there we go. Okay. So we have a VDD and a VSS. And we need a TVS diode. So we're going to add a TVS. What a TVS diode does, it's a diode that basically does nothing until a certain voltage is reached, and then it instantly becomes a short. So it's basically, it doesn't exist in your circuit. That's not fully true, but basically, let's say it doesn't exist in your circuit. And then once a voltage reaches its legs, that is above, in our case, 58 volts, it tries to become instantly a short. It's not instant, it's a range and blah, blah, blah. And then it becomes a short to ground. So if an ESD event hits, so like 500 or 1000 or 2000 volts hits those pins, it'll be sunk to ground through the TVS diode instead of it reaching the IC that's later in its path, basically. That is what that's for. The one we need might actually... Oh, wait, let me move this on the screen. You can actually see. Why can't I make this window smaller? Oh my god. SMA J58. Now, Claude selected a different one, but we'll figure that out in a moment. And basically, looking at the schematic, if we look at our schematic, we see that it needs to have the squiggly on top and then the flat triangle bottom on the bottom. So that means that it can sink current to ground, basically. Oh, wait, now I can't really read chat anymore. Okay. Yeah, voltage surge protection. Yeah. It's not for when a connector is crimped wrong, because this is a transient voltage suppressor. So this is for events that only last like a millisecond or 10 milliseconds or something like that. So it's when you touch something and you hear a little spark, like the zap you sometimes have when you touch something. That's what it's for. Or like when there's a lightning strike nearby, there's some, energy floating around, and you want to sink that to ground instead of it going into the pin of your IC, which will just die. So that's what TVS is for. Transient voltage suppressor. So only for very quick spikes. If you have a dead short, the TVS diode will just burn and die. So, yeah. Okay, so we did that part. And then it says we need a 0.1 microfarad capacitor. Okay. Sure, we where am I? There, we can add that. So we're going to say capacitor, cap small. No, okay. Unpolarized small. This one. Okay. So we need a capacitor, and it's connected in the same way. And we need to tell this, what this is, because now it just says C1. I like drawing schematics like it'll be laid out on the PCB. That's generally not a thing, but that's what I like doing. So we're going to say this is a 0.1 UF 100 volt. Now, why does it need to be 100 volt? The PUE that's coming in is generally 57 or lower, so like 30, 40 volts to 57 volts. And especially a ceramic capacitor needs to be rated much higher because there's a voltage derating. So we're just going to call it 0.1 UF or 100 volt. Let's do some organizing here. And we're going to put that there. Let's move this. With the G button, you can move things and it'll try and keep the connections. Okay. In the meantime, let's see what Claude, this one, came back with. Oh, it needs me to do stuff. Oh no. Okay. We'll keep doing it ourselves, no problem. Then we need the IC. We kind of do need the I do need to import that one because it'll have all the pin connections defined and things like that. If you go to LCSC, we can see, okay, LCSC has a defined symbol for this, the symbol you use in the schematics, and a footprint. So that's good. We can use a tool in KiCad, which we don't have installed, which we will install. Plugins and stuff for KiCad. Oh, wait, I need to turn off the browser. Okay. Okay, move it here. Uh-oh, okay. And we want something that's called import. Import GUI for KiCad. Yes. Oh, it's uninstall. So it is installed? Okay, so it says it's installed, but where is it? Oh, wait, it's in the PCB. Yeah, okay. It's in the PCB editor. For some reason, this tool is only available in the PCB editor and not... Oh, no, I moved the wrong window. Stop it. And not in the schematics editor. Okay. We want this tool. And here we can say, I want to import this LCSC number. Yeah, we need to save this library somewhere. Oh, okay. We have already a KiCad import library. Oh, okay. Good. Okay, import. Yeah, it gives us blot. But it says, okay, it imported the symbol. That's what we need. It imported some 3D models, and it imported a footprint from the LCSC listing. That's basically what Claude is also doing for us now, but we just did it manually. Fine. So now, if we go to add a part, finally you can resize this. It's called the TPE. Okay, it's not finding it, so we need to add a symbol library. Did we add a project specific? Oh, we did add the KiCad import. Okay. Then we need to browse it. Close all this. How do we call it? KiCad import. But it doesn't have any components. So this must be wrong. Oh, there we go. Yeah, okay. There's our IC that we want to use with all the connections. And as you'll see, it'll look different than it does on a schematic, right? So this isn't often not drawn in the same way, but the only thing that's important here is that the pin, so the pinout numbers are correct. So pin 1 is VDD and pin 10 is VCC. That's like the other way around than we want it. But let's see in the datasheet. Datasheet. Yeah, pin 1 is VDD. Okay. And oh, VSS. Yeah, okay. VDD and VSS is a different, VCC is a different pin. Okay, because this is connected to power ground. Ah, okay. And analog ground, okay. So VSS is connected to ground. But our power grounds are over here. But maybe if I can... Well, now you can also see the KiCad a little bit. You can see in the schematic that pin 15, pin 16 are power ground, and pin 11 is analog ground. And we also have those, pin 15, pin 16, and pin 11. But as I said, this schematic symbol doesn't reflect the symbol in the datasheet. But as long as the pins are correct, that's fine. So let's verify a few more. Pin 18 and 19 are VBus. And in our PDF, pin 18 and 19 are also VBus. So that's correct. Let's see. SW is 14. That's correct. BST is 13. That is correct. Feedback is 12. That's correct. Compensation is 8. Also correct. Okay. So the pins are correct. The symbol is just different. And now we'll have to transpose what we see there onto here. But in the meantime, we can see what Claude is still thinking. Is it trying to make everything itself? I didn't necessarily need it to make everything itself. My credits. Oh no. We're at 26%. But we're gonna get reset soon. It's burning everything. Okay, fine, whatever. Right, so you ask Max, you get Max. Sorry, I haven't been paying attention to the chat. Wait, are we actually going to draw something? Yes. I think it did do the D-rating, DFGA. I think the more intelligent models do that nowadays. Okay, so let's see what we do next. We have a CP pin. So, okay, let's connect VDD. Oh, wait. Let's connect VDD to VDD over here. And then there needs to be a 0.22 UF between VDD and CP. Okay. This is going to get messy real quick. But we'll figure that out later. Once we have all the connections, we can work on improving it a little bit. So, let me change this filter back. It wanted a 0.22 UF between VDD and CP. Okay, so we just added that. And then we have this detection here. That wants a 24.9 kilo ohm resistor. Okay, and we have our detection here. So let's say we want R small. And that, oh, where did it go? That goes also from VDD. No. From VDD to DET. Okay, no. And we need to give this resistor a value. It says 24.9 kilo ohm. But I'm going to say that it also needs to be 100 volt. And that basically means we need an 0805 or at least an 0603. An 0402 resistor. You can get special ones, but I generally would try and use it below 50 volts. So I'd go at least 0603 or 0805. I'm just going to note this down so that I know that going forward. I'm going to move these out a bit. Okay, so now we have CPP and detection done. Then we need another resistor from class, so pin 4 to VSS or ground, basically. Okay, sure. And that needs to be a 41.2 ohm. Okay, so we're going to copy this resistor. It needs to go from class to ground. Okay, so I can put it here. Yeah, see, this quickly becomes a mess. I need a ground symbol. Do I have one here? Yeah. So I'm going to add a ground symbol here, basically. And I'm going to pull this one down. Because I believe ground is basically shared. If we look at the schematic, you see that they add a power ground symbol here. And that all of this is basically connected to power ground. So that's basically the same ground. And over here we have the same ground. We have the same ground over here. So basically our VSS becomes ground. Okay. So that's what we basically added here. But that means we can delete these. Oh, come on. So this is ground, this is going to ground, this is going to ground. I like having a central ground, and I always try to get ground to point down. It's not always possible, but yeah, and since we're not going to have anything below these components that are going to ground, I'm going to make this as compact as possible. This is fine. Let's move that up a little bit. Okay, let's see. The next thing we need to draw is okay. We can do the pin 15, 16, 11. Also needs ground. We just made our ground. So if we look, no, wrong one. If we look at our symbol, we can say, okay, if we know this needs ground, let's just tie it to ground. This also needs ground. This is ground. Right, so we saw in the schematic that 15, 16, and 11 all go to ground. So that's what we just did. And we'll probably be moving this in a moment, but you know. Okay, next one. We see that MD. Oh, wait, no, I can't click there. MD has a 0 ohm resistor to ground. Okay, what does MD do? It just goes to ground here. MD, feedback mode and dither function selection pin. See table 2 for the detailed function setting. Okay. Oh, wait. No? Sports frequency dithering by setting the MD pin. During startup, the blah 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 detects output current. Okay, off the V. Okay, ready. The MD configuration option. Okay, so this is for the spread spectrum function. If we want the dither function, and if we want PSR or SSR. Okay. The noise environment capacity. Okay, we don't need that. The capacitance should be. But what is PSR and what is SSR? I think that's the switching mode. Okay, flyback is specially designed for active clamp primary side regulation. The MP can also be set to secondary side active clamp flyback. Okay. Now here we're going to look in the datasheet for the 3-peak part which we're actually using. Let's see what they say about this. So they also call it MD. Okay, feedback mode and dither. Oh, dither function, so it has the dither function, although they don't really talk about it. Oh, okay, they have a nice graph here. Dual triangle spread spectrum. Oh, here they call it spread spectrum, as I always call it. Okay. High frequency train and low frequency, okay, shows the dithering. Right. But do we want PSR or SSR? Because we want the dithering for sure, because that makes it pass the EMI. But I don't know if we want SSR or... Okay. Let's see how far the AI is. Wait, where are we here? It's still busy. I'm gonna have this schematic drawn before it's done. Are we dead yet? 11%. Okay. Sure. You do that, boy. Keep going. High speed, especially designed for active clamp flyback topology, PSR. I think we want PSR. So the evaluation board has MD, oh, with a 6.2 resistor. Okay. What mode is that? 6.2 is PSR with no dither function. Okay. Why would they disable the dither function? Don't you want that? I don't know. But the MPS evaluation board has the MD with a 0 ohm. I think I'm going to follow that recommendation, right? Because with a 0 ohm, we get PSR with the dither function. I think that's what we want. Let's see if chat said anything. Yeah, generally with SMD components, you don't need the bridging stuff because we have multiple layers. But in this case, it's actually a setting pin, right? But we're going to use a 0 ohm. That's fine to ground. And if we need to adjust that, we can adjust that. We can ask the AI later. So MD... Because I kind of understand what it does, I just don't know which mode I want. I don't have an ohm symbol here. Do we have it? Okay, maybe I can copy this ohm symbol. There. Now I have an ohm symbol. Okay. I'm going to add the ohm symbol everywhere. Okay, so now we have the MD figured out. Basically, well, we'll ask AI in a minute. Once it's done whatever it's doing. Jesus. Okay. Let's see which pins are easy to draw. The FSW is the switching frequency, basically. And we're going to follow the evaluation board by setting that to 500 kilohertz. Let's see if that's actually true. Yeah, 500 kilohertz. Let's see, and the other one, the actual IC we're going to use, Oh, they used a 10K. What does 10K do? They also said it was 500 kilohertz. What? Okay, how do we calculate this? So now we have a discrepancy, right? So they say this board is running at 500 kilohertz, but they used a 10K resistor, and these guys say this board is running at 500 kilohertz. Yeah, okay, and they used a 9.31K resistor. Okay, sure. That's probably a case of close enough. Let's see if we can find some something in the data sheet about the FSW. Yeah. Switching frequency. Sure. Okay. The 3-peak, which used the 10K on the evaluation board, says that 9.31K is 500 kilohertz. And using a higher value gives you a lower switching frequency. So they probably saved on the BOM cost by not using 9.31 but using 10K. So it's actually switching slightly below 500 kilohertz. Let's see if we can actually find how fast that then would be. So they say they tested everything at 500 kilohertz, but they really didn't. Because their own evaluation board says they didn't. Okay, they're set by an external resistor. The resistor value calculated by blah 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 divided by... Okay, so if we take 5650 divided by 10,000. Yeah, then we get 465 megahertz. And if we take 4650 divided by 9311, yeah, then we get 499 kilohertz. Okay, so okay. Sure. So chat, what should we do? Do we want 500 kilohertz but have to use a specific resistor? Or do we want to use 10K, which is a very common resistor? So likely that's going to be in the BOM already, so it's not an extra part. So that makes it a lot cheaper, right? Let's see, 9.31K. Let's see if 9.31K is a generic value or if it's a hard to get value. K's 9.31 in stock. Okay, they have 52 versions in stock. I want 100 volt or at least 75 volt. They still have 15 in stock. Availability. Okay, there's not a lot of availability. I mean, having like 5,000 maximum in stock, that is not a lot. Because if we go here and we say 10K, there, you now have 94 versions in stock, and the most stocked one is, it's only 379,000. Generally, it's millions. Okay, but these are much better in stock. What value? $931. So 976 is also highly in stock. Okay, and then we go down to lower stocks. Okay. How about 9.1? 9.1, they do have a lot of stock. Okay. But then what frequency would be running? Let's see. 4650 divided by 91. Then we'd be running 510 kilohertz instead of 500. Okay. Yeah, the question is, how important is it that we run on that exact frequency, right? We're not going to be running on that exact frequency anyway, because we're going to use the spread spectrum blah, so it's going to spread out, right? So the question is if we want to do BOM eval consolidation, basically. And I think in this case we can go for a 10K, because we're not going to use a lot of power, right? We're going to use 1 to 2 watts. So we don't need very high switching frequencies for efficiency and things like that. Because, not so much efficiency. The higher the frequency, the lower the efficiency, but the smaller your parts can become. It's a bit of a trade-off thing. So I'm actually going to go with a 10K, because likely we'll have more 10Ks, and that just makes it cheaper. And I don't really care that it's going to be switching below 500 kilohertz, because we're not that much on the edge that we need that. Yeah, we don't need that, right? And I believe it was wrong one again. I believe we just connect that to ground. Well, we can check here. Yeah, you just connect that to ground. We also have this SS pin, which we can do next. Let's see what the SS pin does. Okay, SS. Okay. Oh, this is the soft start. Okay. Yeah. So basically, when an IC, especially a current regulator, turns on, you don't want it to instantly turn on, because that'll drain a very high peak current. And you kind of want to avoid peak currents when you can. A slew ramp in PSR mode, comp ramp in SSR. Okay. Controls the hiccup protection period. Okay. So let's see what they used here for SS, a 0.22. And let's see what they used here, 0.22. Okay. So we're going to use a 0.22. Oh, we already have a 0.22. Good. So now we have 2. That means they don't have to load an extra feeder on the pick and place machine, because we basically reuse that component. Same with the 10K, right? Good. Let's see what else here. Wait. There. We also have this VCC pin, which I believe has a regulator behind it. No, wait, the V-bus had the regulator. So the VCC, what does the VCC pin do? VCC, internal output capacitor of an internal LDO. Connect more than 2.2 microfarads between the VCC and A ground for the internal LDO. Okay. Okay, let's see what they did here. They did a 2.2. And let's see what they did here. No, here. They also, no, where is it? There. They also did a 2.2. One thing, however, that doesn't tell me is what voltage it is. VCC can also be powered from an external power supply of lower than 6.5 volt to eliminate power loss on the internal LDO. So that tells us it's probably lower than 6.5 volts. But let's see if they have a pin specification. UVLO. No. Okay. Switching. I didn't see anything about an LDO. Yeah. The VCC is regulated at 5 volt. Okay, so now we know the voltage, and we need to know the voltage to select a capacitor, right? But because it's 5 volt, we can use like a 10 or a 16 volt capacitor. And basically, you can go onto LCSC, go to ceramics, delete the search thingy again, and we need 2.2 UF because you want to try and cost optimize this, right? We just said, okay, I'd like a 16 volt part at least, but we can also use a 25 or 35 or 50 volt part. That's all fine. But we want the smallest part, which is also the cheapest. Because we already did the voltage derating, so we need 5 volt. You want at least 10 volt, but let's prefer 16 to 25 volt. So let's say in stock. And then we're going to sort by cheapest. Whoa, $1.20. Okay. Okay. And we see that we can get a 2.2 X5R. That's a decent composition. With 16 volts at 0603. Or we can get one. Oh, we can get an 0402. Okay. Not a lot in stock, but that's fine. We have another 0402. Another 0402. 0603. Okay, so if we limit to 16 volts, which is more than enough derating, because the 25 volt parts, here we have a 25 volt part. But yeah, that's 5 times the derating. Generally, that's not needed. But the price-wise, it doesn't really matter. But you don't want to pick a part that is available but costs 5 to 10 times as much as a part in a slightly larger package, before, for instance, right? Before built, my Dutch is slipping through. More volts? Okay, sorry, I'm not reading chat a lot because it's not in front of me right now. Just do the 9.1. Oh no, I went for the 10K. Yeah, no, we need to do some BOM optimization. I think 10K is good. Let's see, it's the only this. It is labeled one, and that's why it makes me mad. What? Oh, you miss Radio Shack. Mislabeling things makes you frustrated? What did I mislabel? What? Are we talking about what I'm designing, or are you just yapping away AF? Don't forget to amend the value of R2 in the schematic for the correct class setting. R2? Oh, right. Oh, that's right. I didn't. What was it again? Anyway, I think we're going to use a 0402 based on the research we just did, because I'd like this one to be small if possible. So this needs to... What? Why does it go away? What? Okay, this is odd. It needs to be a 16 volt 2.2. And you're right, I forgot to do the MD one. So let's check this data sheet. MD was 6.2 or 0. We decided to go with 0. Did I make the wrong one 0? No, MD is 0. Class. What should class have been? 41.2 ohm. Oh. That's a good catch there, Greg. What? Why is it gone? That makes editing a lot harder. 41.2. Maybe this is a KiCad 10 bug. I don't know. 41.2. But yeah, how much current is... Okay, this is a sense pin to set a pin. So there's not a lot of current going to be there. So we're going to give this 0402. And it doesn't need to be 100 volt. 50 volt 0402. It's likely based off of the 5 volt from the VSS that they're using internally. Right? So, yeah. Or the VCC. Did we connect that VCC already? No. And we decided... Oh, I edited the wrong one. Okay, hold on. VCC, ground. See, this is how errors slip in. No. 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 Give me the stupid label. Yes. And I know this one needed to be the same as this one. So we're going to delete it. And put this one here. Okay. Now we have comp and V diode. Okay. Let's take a look at how our AI is doing. Oh! What? Claude reached its tool use limit for this turn. What do you mean? It did all that for nothing? And what? It did my account blow up? Okay. No, not yet. Oh my god. What does that even mean? Okay, so the generator's written but not yet executed. There's no zip to hand over yet. Okay. Okay. Build coordinate for coordinate from the MPS recommended LAN pan, and oh my god, it started building all the footprints itself. I didn't really want that. Oh my god. Why would you do that? Verify flags in the sim. Oh my god. Okay. Yeah, I don't really know if I wanted to do that. No, I don't sketch things out on paper. What the hell? That's why I have an editor. But yeah, I mean, I don't really need it. I never needed it to do that stuff. I just thought it'd be funny if it could do those things for us. I didn't realize that it would start drawing the schematics or the symbols itself and the footprints. I didn't need it to do that. Okay, I think I'm gonna leave the Claude for what it is right now. Yeah, we could burn through another few $100 and, you know, get some result, but if it's going to be useful for our case, I don't really know. So, yeah. Let's go back to our editor. This has gotten a bit cramped, and there's still a few pins here. So I'm going to say, let's move this over here. There. And we can keep working. Let's do the comp and the V diode, and then we might call it a day, because the other pins are a lot more complicated, I think. So let's take a look here. V diode needs a 150K or 150K. VDIO. Is that the same? Yeah, okay. This is pin 9. Yeah, okay. That is the same. Okay, so let's take, I don't know, this resistor is an 0402 V diode. Let's do that. Oh, sorry, you can't really see what I'm doing. So we just copied it, and this was supposed to be a 150K. There, and then we have a so this is the overambitious cheerleader that you can do anything. I don't rely on the tricks. Yeah, but I might want to use those credits for something else. I don't know. And it's not really something I can't do myself. I mean, I can keep the AI going for another few hours and then get something, but I don't think it's going to get me anything that I wouldn't be able to do myself in the same amount of time, right? So use the AI what it's good at and not so much for everything, because it clearly, spent a bunch of time doing stuff I didn't really need it to do. The comp. Oh, we need a compensation circuit. Oh, I hate compensation circuits. Okay. Okay, we'll make the compensation circuit. Let's see what they use. So we have a comp pin, and that is a compensation circuit. It's something in a DC-DC converter design I am not really going to explain right now. They use a 1K and a 22 NF, and what these guys use a 3K and a 22 NF. Why? Why? Okay, comp. Where is my data sheet? Feedback loop control pin. Yeah, okay, sure. But how do I calculate your comp? There's a lot of comp in here, sorry. Oh. Do they not have a separate section on comp? So here we can go to the AI again. This would be a fun question for the AI, I think. Because I don't need it to do all the other crap. In the two evaluation board designs, I see different values for the comp being used. What changes with the different values, and what would be best for our situation, given we only need 1 watt, 2 watt out? So this is what I use AI for more often. I don't really use it to do those other things, because I can do those easily myself, or quicker even. But now we have this discrepancy here, right? So we have this comp pin which has a 3K and a 22 NF and non-connected. That's fine. And a 1K and a 22 NF. Generally, the 1K probably means versus the 3K that the this circuit is more dampened because it lets through more current than this 3K one does. But I don't know in this situation how much dampening you want on the compensation circuit, and The compensation circuits are complex, right? So I just asked the AI, okay, why is the two data sheets different? And what do you think would be the ideal values for our use case? So we can tune the compensation circuit, because that's what you generally do, to your use case. Right. I can't really handle this without a mechanical pencil and a reverse polished graphing calculator. Oh, its brain cracks out. Okay. So this is what I use the AI for more often, to basically spar with and do research with together. And most of the time I understand all the things, but it's hard to evaluate everything at the same time. And then you can ask it like, hey, what do you think the ideal values would be? And then it gives you an explanation why it thinks that, and then it can help you in understanding the circuit and what would be best in your case. Oh, generally it gives me the correct answers, AF. But you need to use a good model for that. Yeah, that's what I expected. If you need 12 watts or if you need 1 to 2 watts, you need a different compensation network. If your AI answers really quickly, it didn't do a lot of thinking. Are we excited yet what actual PCB development entails? I think most people would have expected me to be laying out tracks and creating giant power planes and whatever by now. We're going to do weeks of this stuff. You're going to spend the most time reading data sheets, figuring out things, drawing schematics, matching parts, and then we get to the PCB side. And then we're going to do weeks of that. We haven't even done one part yet. Granted, these are the most difficult parts, I think. I hope. But yeah. Cool, Foxionaire. Glad to hear it. Repositioned visual focus to examine schematic details. Deciphering schematic pin assignment and component layouts. Ooh. You need to have this AI computer voice woman shouting these things out, right? You've gotten 50% lies. Oh, wow. You hope the machines don't come for you. I don't know, AF. Yeah. Yeah, sure, Jade. Yeah, as I said, I don't mind doing schematic work and research. That's what I like to do, to come up with innovative things, right? Copying something that someone put online that maybe copied it from someone else, that probably copied it from someone else, and during the chain, not everyone fully understood everything. That's generally a lot of boards you see out there. I don't like that. I like to understand what I'm actually doing, why certain choices are made, and make my own choices in that, and then build it, actually test it, evaluate the choices, adjust, do it again, until you arrive at what I think is the optimum configuration or board for whatever given purpose, right? Yeah, but that takes a lot of time. You just wanted your effing WLED controllers to work in a hotel situation, and they lasted a whole 2 minutes. Okay. What happened after the 2 minutes? Yeah, but after this, we're going into the secret, and then we'll close it off for today. Sure, but in the end, you also have to get a functional painting. GMC engineer, okay. Yeah, and it really depends. If you're asking like free tier chat GPT, you're gonna get a lot of bogus. But if you're paying like $200 a month and using the most expensive models on Earth, you might get a bit better answers. But then again, you might be burning like a lot. Okay, I think while it's doing this, we're gonna look at something different. The secret of the week. And that is, okay, I need to disable the transparency here. And that is this. I have been working with AI on a few websites, and one of them is the new QuinLED.shop. So QuinLED.shop, okay? And that has all my boards on there, available from all the different resellers. So if we go to, let's go to digital, we see a bunch of text, blah, blah, blah. We have a little comparison table here of the Dig2Go and the Dig Next. Let me disable the YouTube there. The Dig Next, the Dig Uno, Dig Quad, and Dig Octa. Some basic statistics from them, etc. We can go to, you have an overview of all the products that are available. We can go to the Dig2Go. And here we have the Dig2Go. It's available from these resellers. So if I click here, I go to AllNet. So the way I'm selling hasn't changed. We still use all the various resellers. Or if I go to the NL page, etc. We even now have a reseller in Denmark. His web server is a bit slow. I don't know. Sure. There, we can buy it in Denmark. Okay. Or Scandinavia. He also has cheap shipping to Scandinavia. And there is a little bit of information here. This one actually has a few bundles, so we can see where the various bundles are available. A bit of text. But I went even further with my AI powers. We can go to the documentation, and then we arrive on QuinLED.info and we get the documentation we've always had. Or we can go to the web installer. So this is a quick and easy way to navigate to the web installer page for the particular product. We can go to the intro video, or we can go to the dig2go.info, which is a website that already existed. It had already had an attempt on there, but I've revamped that. And you go to a dedicated website for the Dig2Go. And it has a bunch of cool stuff on there, like an effect simulator, like, oh, what kind of effects can this board do? Well, it can do all kinds of effects, and it has some nice imaging that well, these are my own photos. These are not AI generated. But AI really helped me generate this website, though. Yeah, they have some statistics and like QuinLED stuff. Yeah, built by QuinLED. We got some, statistics. This is all the same information that's available on QuinLED.info and has been for years, but then basically revamped. We can go back to my documentation here. We have a little bit of a diagram where we have the positive voltage, the data signal, and ground, and your LED strip. And we have a little getting started guide. where you get some tips on how to connect everything, or you can go to the pinout guide. We have an FAQ page, so a frequently asked questions are like, can I get a cheap remote, or do I have to solder anything, and how do I run RGB strips? Can it work with 12 or 24 volt? We get that question a lot. How do you set it up? Like, okay, we have WLED AP or Quin LED AP. How do I do music reaction? Oh, you have to set the pins and things like that. All kinds of questions. And then we have some AI generated example images, like you can put LEDs behind your monitor, or you can put them behind your TV. That's Dig2Go is really good for that. Behind your bed, sure. You can do multi-zone stuff. If you want a warm white bookshelf glow, you can do that with SK6812. That'd be cool. Or like a cozy corner in your room. All AI generated photos, always good. Then you have my intro video. It asks you a few questions to determine what you might need, the various kits and bundles that are available, and then it basically loops back to the shop if you want to buy one. I thought that is a more user-friendly experience than QuinLED.info has been in the past, right? The QuinLED.pink. Is it actually a domain? We'll check it out. Okay. But if we go to the Dig Next 2, well, I've been busy. We have another website, but this time it's for the Dig Next 2. And this lighting thing lights up a little bit, and it's funny. And here we have a few boards. These are still in development. Hint, hint. We can go to the Dig Next 2. And it has all kinds of statistics and a nice little funny animation here. 5 volt to 48 volt, all kinds of statistics about the board. More wiring diagrams, setup guides, more example photos. So this is more with puck lighting, for instance, or the aspect ratio seems a bit off. Need to look into that. Yeah, this is being stretched wider, it feels like. Okay, we found a bug. That's okay. Okay, intro video, more questions and Q&As. And again, you can buy it on the QuinLED shop. But if we go to analog, and we go to, I don't know, the AN Penta Plus, we got some nice photos here and things like that. Oh, nice. Where can I buy all of this? And guess what? There's also an anpenta.info website now, which has the whole lineup on it. And it actually has some cool displays. Like, if you're doing low PWM while filming, it's like this. Wait, where am I? This exact scenario. That's why I'm using all my own boards. You get this stupid banding, but if you use my boards, you don't, because you can do PWM at 20 kilohertz. Cool. Okay. And since this leans more into... we have a fusing simulator. Yes. So we can simulate a broken fuse, and the other channels keep going, but you don't burn down your wires. And we have a CCT simulator, so here you can, see what kind of warm white or cold white you'd like. I use all my filming lights at 4300K, I believe. So it's a bit in between. We have some more examples here. Some color or some workbench lighting, for instance, with very AI generated circuit boards, because none of this makes sense. Demonstration. These book titles, you can't read them. That's okay. Some stuff about ESP Home and WLED. Some more articles which are based on my own articles about PWM and flicker and things like that. And I believe even we now have some, if we go into a board, I have some more diagrams and things like that. In the Getting Started guide, I believe I now also have some ESP Home code in there, which should work with the newest version. Only the part for the LED dimming, not the whole configuration. But you can go to install.quinled.info real easily. You can go to WLED, or you can go to the rest of the documentation that's still on quinled.info. But it's basically, you can go to where to buy, and then you go to quinled.shop again, and it's a whole circle and loop thing. And then last, I think I made one more website. This one, we also now have a Dig Octa website. Still working on that one a little bit. But it has like a little diagram here about having brain boards and power boards. This took a lot of prompting. It's still not great. And top boards, which we'll have in the future. Some more statistics, and that you can mix voltages in a stack, and that you can grow it. Then you have all the boards nicely displayed here. So we have the current brain board. We're going to have different brain boards in the future. We have the Power 5, the Power 5 HV, Power 7, Power 7 HC. And these are all my own photographs. Those are not AI'd. I had those all along. I just didn't have a nice way of presenting them, I guess. Right? So you can go into the Power 5. You can get some statistics there. You can do 50 amps. And you have a board photo here. You can go to the Getting Started guides, and it gives you some tips like, oh, you need to connect with what kind of wire you need to connect on. You can click on the forks, and then you can go to my article about forks. All information that it's not necessarily new, but it's structured a different way to try and draw in a new crowd, I guess, right? That's the idea. These are all diagrams I made years ago already, but they do explain everything really well. And you can go to the other boards, or you can, buy it at the QuinLED shop. And there we go. And the Dig Octa system is like build your system. So you can choose a brain board, and you can choose the power boards, and all kinds of stuff. But especially the shop page is something that, with more and more resellers, it became very hard to track for me and to keep up. And this is a lot easier to maintain. And I think it's a lot nicer presentation, right? And let's see, a great fuse feature. New cars have super irritating flicker. Yeah. Whoa, I'd look at some YouTube tutorials, Greg. And I haven't done many, but there's lots of YouTube ESP Home content out there. And then start playing with some example configurations and playing on a board and testing it out, and then you'll get the gist of it. Well, I have done some with other boards where we made an ESP Home configuration, but yeah. You have been busy. Claude has been doing a lot of things for me, because this is also running on a different web host. And I did all of that in a week. So, I'm really proud of the store it became, but I couldn't have done it without Claude. That's why I have that expensive plan. So I generated all these websites for like $200, right? And I think it's a big improvement versus what we had. Also, because of SEO and GEO. So these websites and all the interlinks and things like that will help a lot in ranking in the search engines and also in the AI answers. Because as I said, it's not so much new content versus what was on quinled.info already, but it is better laid out for humans and AI, basically at the same time. So that my articles and my boards and things like that will get recommended by AIs and search engines and things like that versus not, right? So that's the idea. What's the difference between the Claude, Gemini, and ChatGPT? A vendor, right? They're different companies trying to do the same thing, and they tune for different things. So Gemini, for instance, has a really nice image generation model where Claude can't generate images at all. But Claude, then again, in my opinion, understands technical things a lot better than Gemini does. And ChatGPT is more for generic stuff, but also has an image generation model, and it probably has some other stuff it's really good at. So, yeah, it kind of depends on what you do, it would work best for you. They all can do most stuff, but some just excel at some things, right? So, yeah. Wait, I needed to look at a website. What was it? Aw, I can't reach QueenLED.pink there, Johnny. It doesn't exist. Was it a different website name? No, it was QueenLED. Sorry, I can't reach QueenLED.pink, Johnny. I tried. Yeah, but I don't know. It still needs new photos and things like that, but generally, I think it's pretty good, and I hope it'll drive new traffic to, my boards, the website, information, YouTube, etc. It only works on Johnny's local network. Aw, I have to click your link. I don't know. Okay, I'll do it because it's you. Wait, are you sure you want to leave YouTube? Yeah, okay, go to site. Uh-oh, my monitor turned off. Why? No, it's not off. What? Why am I... Johnny, what kind of virus did you give me? One of my monitors is off. Hold on. Okay, it's back. Good. Johnny made us QueenLED.pink. This is also AI generated. It's different. I think mine is better. Click my link, not sus at all. Exactly. I heard that, that sus music. Anyway, let's finish for today. Yeah, I wanted to show off the QueenLED.shop. All links on QueenLED.info to the various vendors have been replaced with QueenLED.shop links. So you'll end up here. You can select the board you want to buy, and then select the reseller you want to buy it from, and it goes directly to their listing, etc. So let's see what it said for our compensation network. The error amplifier in both parents is accurate in current. I'll say a feedback sampled. Okay. Blah blah blah. Why the two EVMs differ? Two reasons. First, the chips aren't identical inside. Okay. So it has 14 microamps, nanoamps. Yeah. And on 3-peak versus 12 on the MPS. The V diode gain is also different, and the F scaling is wildly different. Oh, okay. So FSW 10K for 500 kilohertz on the TPE. No, that's not correct. That's incorrect, right? We went here. FSW. This is the TPE datasheet, and it said for 500K, we need a 9.31K resistor. That's in the datasheet of 3-peak. And here it says the FSW, frequency switching, 10K for 500 kilohertz, wrong. Needs 150K. Is that true? Where is the datasheet? Okay. Yeah, this one also says 9.3K for 500 kilohertz. Let's see their calculation formula. 4650. Exactly the same. So this is where the AI is dead wrong. Right? And if you use a 150K, you get very different results. Okay, so it uses less gain. That's what I already said. Okay, sure. Let me try and interpret this. Hold on. So MPS. Okay. So it's recommending a 10K. Yeah, but for some reason it's now assuming we're running at 300 kilohertz, which is not true. No. It's lost its mind. maybe, but it had that completely wrong. Later, Foxionaire. Saxophones start playing louder. Oh. Yeah, so this is again AI. Even with the best model on Earth in its best thinking mode, it just made a mistake. And now it's recalculating for 466 kilohertz, which is correct with the 10K resistor. That is what I also calculated. So even with the best AI on Earth, it did it wrong. Check the I don't know how to check the tokens in the chat. And I'm also working in a project folder, so it should keep memory. I have memory enabled. Your EVL mapping was inferred from the bomb adjacency. Never read off the... It didn't read it. No, it just didn't do it. It didn't do the work. You moron. I told you to do it, and it still didn't do it. It just said, I kind of guessed that. I was wrong. Oh, sorry. Oh, wait, you can't really see me. Yeah, it just guessed it, and then it was like, it got caught. You told the AI to stop being lazy in the past. Yeah, maybe I should add in my generic instructions that if I give it a datasheet, it actually needs to read the datasheet. What the fuck is what is bomb adjacency? What? It was near enough? close enough. You asked me to calculate. Well, feels close enough. I think it's okay. I burned a lot of your money, but it's close enough. Acknowledging error and recalculating. Very good. You do that. You were right on both counts. Oh, really? And the schematic settles it. EVM board 9.31 sits. Yeah, okay. Is V diode. Oh, the clones agree there too. Okay. Oh, really? Oh, okay. Yeah, 9.31 is 500. 8. Yeah. So different claim is retracted. Thank you. Along with the 15.8K suggestion built on it. The real chip-to-chip difference. Sure, that's probably true. Yeah, that's exactly what we also discovered, that MPS did true 500 kilohertz and 3-peak rounded it. That's fine. Sure. Okay, yeah, that's fine. Spanning roughly 420 to 513 because we have the spread spectrum and we have the tolerances of the parts. Sure. Yeah, that we also verified. That's fine. Comp recalculated. Okay. It's still recommending us the 10K. Okay. 1 to 2 watt. You're in DCM boundary. Yeah, sure. Crossover lands below both stock network zeros. Okay, sure. We need to boost it. Okay. One watt and 57 volt. The on time is 244 nanoseconds against the 200 nanoseconds minimum. Okay, sure. And the constant frequency minimum is 0.0 at high line. Oh. If the panel ever idles below 0.7 watt, expected pulse, burst ripples, and okay, that's the part number. No sleep mode by design. Not in. Okay, yeah, okay. So DC converters generally have a continuous mode, and that's where they're most not so much most efficient, but most quiet. So if you want to pass EMI and things like that, that's important. And if it falls below those values, it'll go into pulse mode or skipping mode or whatever they call it, and it'll lower the amount of pulses. Is going below 0.7 watt a problem for EMI, or does that mean different parts or compensation network could be more ideal? Because we're, with the display panel, it's not going to draw a lot of power. We can see how much power it draws, right? I'll read chat in a second. Hold on. So if we zoom out a bit, there we can see my power meter. And if we connect our little screen here, it doesn't have the Ethernet circuit on there, but we can see it drawing 1.3 watts, 1.4 watts. Okay. So it's drawing 1.4 watt, and that's actually the Ethernet hardware is on there, and I believe it's also active. It just doesn't have anything connected, right? So it's having Wi-Fi and Ethernet active. But we're drawing 1.4 watts, so a 2 watt load with everything we're going to add might actually be realistic, right? Still well below the 6 watts or whatever, so we're still going to be in that class 2, so designing for that is good, I think. But it's using a little bit more than I thought it would. Maybe once it's idled and the backlight's lower or whatever, it'll go back to 1 watt, but it's still more than the 0.7. So this question I just asked, it's not really that important because it already gave us the ideal values for what we're actually going to be using. Okay. So I'm actually just going to stop that because it told us what we need to do. I am going to ask it, is our because ESP32s can have very rough current draws, especially the original one. So you kind of want to make sure that whatever you're designing can react fast enough in scaling up and down the current it delivers. And the compensation network is basically the measurement for that, how fast it'll react to transient spikes. And if the circuit you build is too slow, basically, it can brown out, so the voltage will sag if there's a giant spike suddenly. Like an ESP32 will run at 200 milliamps continuously, but then if you suddenly do some Wi-Fi stuff, it'll spike to 600 milliamp real quickly, and if your circuit design can't handle that, it'll brown out and crash, right? So that's what I just asked it. For now, I think we're going to copy the 1K and the 22 NF. And I'll keep digging into this a bit more with the AI and my own calculations, what the real value should be. But for now, we're going to do the 1K and the 22 NF. Okay. So we need a resistor. And this is a 1K. I'm just going to follow the data sheet here because they didn't choose those values for nothing. Yeah. Do I have a small... Okay. I'm going to copy this guy. This is a giant mess. (22 NF). I think 50 volts for this is fine. And then they have a non-placed capacitor over here. So we're going to add that, and then in the specifications we can say exclude from position files and do not populate, and we're going to call this NC because it's not connected, not placed, whatever. But they have it on their schematic, so I kind of want to have it too. Let's see if the 3-peak one did something different. No, they also have a non... Yeah, okay. So that's generally to smooth things out, right? To have an extra capacitor over those nodes. But in the end, they probably didn't need it, so they leave it non-connected. But it can be good to have. I don't think we're going to have it on the board. Maybe the pads, but I don't think we're going to even have the pads. So, yeah. Okay. So this is where we are today. We did a lot of with AI, but we also did a lot of data sheet reading for the component itself and the evaluation boards, which kind of helped us come up with a design and a way forward. Like, we're now going to go 12 volt and then buck convert that down, maybe have some LDOs for some other stuff, instead of going to 5 volt directly, because sourcing parts is just hard. And generally, if it's hard to source a part, it'll also be more expensive. So then it's better to go with the generic version, which is basically based on. So it'll be cheaper to produce, even though we need extra parts. It'll still be cheaper probably than the 5 volt version, where you need a custom transformer and things like that. Okay, that's looking good. Next week probably we do the other side, and that's going to be even more complicated, because now we just did some resistors and capacitors to ground and things like that. Here we have to do inductors, and inductors, you need to search for them and things like that. It's not too hard. Here we have to transformer. We need to figure out the exact pins for that and things like that. It's not too hard. We can get through that next week. And then we'll have like 5 volt or 3.3 volt out. Oh, sorry. We'll have 12 volt out. Then we need to add a buck converter. Oh, man. But we'll figure it out. All good. All good. Cool. Let me read the chat for a bit. Let's go to the face. What is the chat saying? Even AI must be told to read the effing manual. Yes. Where did I learn all the circuit stuff and do it for you? Well, it is my job now, this channel and the boards and things like that. I do it full time. Before that, I was an IT consultant. So I did 20 years or something of IT consultancy for large backup and storage systems. I designed those and implemented those, troubleshooted those, things like that. Electronics design was a hobby, and it's grown over the years. So I'm mostly self-taught. Yeah. Yeah. You mean the screen will probably drop down? Sure. But once Ethernet is actually connected, maybe Wi-Fi is turned off. I don't know. But let's say it'll draw 1 watt still, and that's still above that threshold, so that's good. All hail the bulk capacitors. Yeah, but they can only compensate so much, so your transients need to be good. So you've always been a genius. I don't know about that, Greg. I don't know about that. Let's wait. Let's quickly take one last look at the AI. Yes, and the reason is worth spelling out, because the flyback is the wrong place to look for speed in this chain. Okay. 350 milliamp at 3.3 volt microseconds. Yeah, sure. Okay, they say, okay, we need more capacitors. 10 to 40 times faster than, okay, sure. Yeah, he's right. We're going to have a buck converter between this converter anyway. So that can also soak in a lot of transients. So he calculated what a C6 Wi-Fi burst will do and a P4 will do on the 1.2 volt rail. Okay, sure. Oh, it's a 1.2 volt dip. Okay. Oh, that's actually a lot. But it recovers in milliseconds, sure. A buck input that momentarily sees 10.7 volt instead of 12 doesn't even notice. So, yeah, it's right there. So it says, okay, if this transient hits, the 12 volt line might not be able to sustain that and might dip real quick to 10 volts or 10.7 volts. But if you have a buck converter after that, which is actually powering your things like the ESPs and things like that, it doesn't matter if it gets 12 volt in or 10 volt in. the output of that buck converter will still stay stable. So as long as that's able to handle the transient, the 12 volt rail dipping slightly is not going to be a problem, unless you're using that 12 volt directly. Yeah. Yeah, it's basically telling me make sure you have enough capacitors on there, and then it can handle those transients. And it's basically saying to me, hey, you're 0.7 watts. If you have an ESP and 2 ESPs on there and the Ethernet PHY, you're going to be above that anyway, so what are you talking about? And he's correct. Yeah, so yeah, it pretty good, pretty good. Exactly, Rob. That's what I also do often. So yeah. Lithium batteries. No, we're not going to use batteries in this thing. So yeah, great progress today. We went for more than 3 hours, and I know it feels like we didn't get anywhere, but this is how much time it takes to design a new circuit. Other circuits will be quicker because I can just copy designs I already did. I already have some parts in mind. So that's how it goes. Just designing something new takes a long time, and then we still need to test it and probably make a revision to make it better or whatever, right? So yeah, you can if we would have taken that module, which is like $2.5 or $3, we would have had a lot less research time because then they already did the research, but we wouldn't be able to fit that on the board space-wise and things like that. So yeah, this gives us more flexibility. Yeah, hope that is clear. Thanks for struggling with me through this schematic design again. We'll continue this in the future. And yeah, give the video a like. Make sure to join the channel if you haven't joined yet. And enjoy the new website. I put a lot of effort into that together with Claude. And yeah, see you guys the next time. Bye-bye.
To the end for it, kiss me again. Shut up and drive. Shut up and drive. Shut up and drive. Shut up and drive. You and I. Just shut up and drive.
We're back. Wait, I'm still here. Rob Keen just donated $10 just because. Well, it'll go into my AI fund. No, thanks, Rob. That's really appreciated. Thank you. Bye-bye.